Good afternoon, all the students of second year. Now today we will see the remaining drug modifying factor. The first, accumulation is an important factor. Is an important factor. Accumulation means accumulation of drug in the body accumulation of drug in the body following its repeated administration. Is called as accumulation. It should be happen due to the slow excretion of the drug due to kidney or metabolism is slow for liver disease. And this produces to the toxic effect. Example of that such a drug is digital is excreted very slowly, and their dose should be very carefully adjusted. That is called the accumulation effect. You understand? Again I can repeat. Accumulation is accumulation of drug in the body. It's repeated administration. This phenomenon is called as the accumulation. Why the accumulation is occur if the drug excretion is slow by kidney or metabolism is slow because of the liver diseases, and they produce the toxic effect. An example of such a drug is digital accumulation. They are used very carefully. Another example, digital is used in the treatment of CHF, congestive heart failure. Another example is this phenobarbital used in treatment of epilepsy. That is convulsion, seizure, मराठी कॉल एज फीट मिर्गी हिंदी में बोलते हैं उसको. ओके. Another effect is next should be the whatever number you can give, synergism. The effect of drug can be potentiated or reduced. The effect of drug can be potentiated or reduce when two or more drugs are administered concurrently. When the presence of one drug enhance the effect of other drug is called as synergism. See the example that you can understand. 1 plus 1 is equal to mathematically is 2, arithmetically is 2. That is sum of two drugs. Now what do you mean by the synergism? 1 plus 1 is equal to 4. The effect is double or more than that. Okay, how? See that when why the drug you can take it shall be potentiate your body is increase the effect of the body, or sometimes they produce the adverse effect, they reduce the effect. When two drugs are administered concurrently, एक के बाद एक दूसरा drug, when you can take it is administered, that first drug, one drug can enhance to the that another drug. Enhance, they increase their potency and they produce the effect. 1 plus 1 is equal to 4. That is called as the synergism. Okay, it's a very quite simple. This phenomenon is called as the synergism. The one drug enhances to the another and they produce the effect more than some of the drugs. Mathematically is called as the synergisms. Stop. So the next, the additive effect. When two or more drug combination is given just equal to the sum. See how. When the effect of the combined drug is just equal to the sum effect of individual drug is called as additive effect. Example, simply 1 plus 1 is equal to 2, that is the sum of mathematical. Similarly, two drugs combined together is administered and then they produce the effect. The effect is produced just like a individual does not enhance, the one drug enhance to the another. The effect should not increase. The effect should be those effect having the individually, they are given in the combination. A plus B is equal to A plus B is equal to AB. That is the effect, that is the individual sum of the effect. Is called as the additive effect. Okay. Now the next, now example, see the another, it's another example of the additive example. See, ephedrine and aminophylline, these two drugs are combined together and is given to the asthmatic patient. The effect is produced as additive effect, just like 1 plus 1 is equal to 2. Okay, stop. See, now the next factor is antagonism. Antagonism. The opposite action of two drugs on the same physiological system is called as antagonisms. Now two drugs react, they are produce action opposite. For example, plus minus 1 plus 1 minus is equal to 0, that is plus minus is equal to 0, like that. A plus B drug, both are acting opposite to each other. A drug blocked by the B, A drug action blocked by the B drug block the action of A, then they produce the effect should be the nil. They are get the neutral, the action of A. Okay, that is a antagonisms. And when the antagonism, the two drugs react each other, they reduce the action. They reduce the action of drug. That is called the antagonisms. Okay. Now there are the so many type of antagonisms. Antagonism generally shows the blocker. Agonist blocked by the drug. Agonist blocked by the antagonist. That is called as the blocker. They are type. Write down first. Chemical antagonisms. In the chemical antagonism, the drug is totally abolished. The drug is totally abolish or reduce the chemical action. In between the two drugs. That drug completely abolish or reduce the action of in between the two drugs is called as the chemical antagonisms. Example, it's a very quite simple example. Acid and the alkali. Acid plus alkali, we will get the, it's neutralized to each other, we will get the water. They neutral the both, you will get after, that is a neutralize the action of each other. A plus B, two drugs is produce opposite action to each other and then completely abolish and they get neutralized. That is called as a chemical antagonisms. The next type is most important, competitive antagonist. Competitive antagonist. The competitive antagonism is reversible and can give the large dose of the agonist drugs and can by overcome by giving the large dose of agonist drug. Okay. Is called as the competitive antagonist. It is irreversible process and it can overcome by giving the large dose of the agonist drug. Agonist drug, the drug bind to the receptor, they form a complex drug receptor because of the affinity, and then they produce the desired effect, that is called as the agonist. Now the example of the antagonist, atropine is reversible antagonism of acetylcholine. The acetylcholine blocks the drug action of atropine. That's why it's called as the antagonisms. The two drugs opposite action on each other. They block the acetylcholine, block the atropine sulfate. Atropine is act as a irreversible. That is an example of competitive antagonisms. Okay. Now the next is a non-competitive antagonism. It is non-reversible. It is non-reversible and generally it is usually combined to the combined with receptor by a covalent bond. Now agonist is act beside joined with the drug bind to the receptor. Because of the having the affinity drug receptor complex, then they are bound to each here by covalent bond. Binding is covalent bond, that is a not breakable bond, if not break, and that's why it is a non-irreversible. It is called as a non-competitive antagonist. Example that phenoxybenzamide is a non-reversible antagonisms of adrenaline. It's a example. Okay, now see again the agonist. What do you mean by the antagonist? Antagonists, two drug opposite action on the same physiological, that is antagonist. Antagonist drug are reduced to each other. They reduce the drug action. Is also called as a antagonism. They are the following types: chemical antagonism, competitive antagonism, and the non-competitive antagonisms. The chemical antagonists, they are chemically the one drug abolished to the another two drugs action. For example, acid plus alkali, it get neutralized, then get neutralize the drug action of each other. They get the water. Okay. Now second, competitive antagonist, it is reversible antagonist. It can be given the large dose of the agonist drug and they overcome by given the large dose of agonist drug receptor combination. Then the affinity, they form a complex and they produce the desired effect. And the example of that, atropine is reversible antagonism of acetylcholine. The acetylcholine is a agonist and their antagonist is the atropine. Agonist is a atropine. Now next class is a non-competitive. It is a non-reversible. Previously you can see the competitive, it is reversible. Okay, and it can be bind by a drug with receptor by covalent. It is a unbreakable bond, and that's why it's called as a non-reversible. It's called as a non-competitive. Example of that, phenoxybenzamide is act as non-reversible antagonist is adrenaline. Adrenaline is agonist. Adrenaline is a agonist act by the phenoxybenzamide is act as a antagonisms. Okay. Now this important topic is over. Now this important topic is over.
मैसेज करेंगे तुमको.
Another see the last.
नहीं आपका भी मैसेज आएगा हम तुमको. मैसेज नहीं तो मेल पे मैसेज आएगा. ईमेल आईडी पे नहीं तो फोन.
Genetic factor.
फोन करेंगे हम तुमको.
Genetic factor is the last factor. There is an individual variation effect of. There is individual variation of the effect and toxicity of drug. The effect with the same dose may get greater in one individual and less in the another. And genetic factor is hereditary due to the hereditary enzymes deficiency due to the hereditary enzymes in the genetic factors occur. Example of that, Rimoquine produce the hemolysis in the individual with often enzyme glucose 6 phosphate dehydrogenase Gb6PD. Okay, now this chapter is finished.